All right, so the fifth section here is about derivatives of trig functions and logs. So these are kind of more basic derivative rules, derivatives of your trig functions and then your logs. So these are the derivatives of all 6 trig functions. You really should memorize all of them. Sine and cosine, derivative of sine is cosine, derivative of cosine is negative sine. How I remember it is that the derivatives of anything that starts with c are negative. So you'll notice derivative of cosine is negative, derivative of cosecant is negative, derivative of cotangent is negative. And then I remember tangent and cotangent are very similar to each other. Cosecant and secant are very similar to each other, just opposite functions. Okay, so derivative of sine is cosine, derivative of cosine, negative sine, derivative of tangent, secant squared, derivative of cosecant, negative cosecant x cotangent x, derivative of secant x is secant x tangent x, and derivative of cotangent is negative cosecant x, or cosecant squared. There is some sort of, I don't know, acronym or something that can help you remember them, but I don't know what it is, to be honest. So I just have them memorized. This is something that I've used often enough that I have it memorized. I used to just know sine, cosine, and tangent, but I have the rest of them memorized as well. So in the example, a coefficient on the sine is going to stay there when you take the derivative. So the 3 is going to stay there. Derivative of sine is cosine. Derivative of 2x, the 2 stays there. Derivative of x is 1. All right, this one, derivative of 5 minus cotangent. Derivative of 5 is 0. So we leave that off. And then we have negative cotangent. The derivative of cotangent is negative cosecant squared. So we're going to have a negative negative. And obviously in your head you can say, oh, that's positive. And just say, oh, that's cosecant squared of x. All right, you do need the x behind it. I know I'm saying cosecant squared, but it's really cosecant squared of x. All right, there's one for you to try. We can also find equations of tangent lines for these as well. That's our biggest application, at least at this moment, of derivatives. We will get into some of the more applications of it later after we learn all the derivative rules. So those of you that I know on the whisk are saying, how does this apply to real life? You'll find out. Just wait. We have 2 whole chapters of applications. So find the equation of the tangent line to y equals cosine x at x equals pi over 2. So when we find the equation of a tangent line, we need slope and we need a point. So our point, the x coordinate is pi over 2. We need to find the y coordinate, and how do we find that? By plugging x into our equation. So cosine of pi over 2 is what goes right here. So cosine of pi over 2 is 0. And then our slope is the derivative. So derivative of cosine is negative sine. And we need to plug pi over 2 into that because we can't have a slope that has an x in it. So negative sine pi over 2, sine of pi over 2 is 1. So this is negative 1. So this is why we needed to know the unit circle, is for problems like this, because you'll have to do stuff like this on the AP exam, maybe even your test, without a unit circle. All right, so we write the equation on the line, y minus our y coordinate equals the slope times x minus the x coordinate. And of course, you don't have to write the minus 0. It's just y equals negative 1 times x minus pi over 2, or negative x plus pi over 2 if you wish. All right, derivatives of logs. So the derivative of the natural log is just 1 over x, derivative of the natural log of x. If you have anything else inside the natural log, you have to be able to simplify it down to just the natural log of x for this section. When we get into the next unit, you'll be able to take the derivative of the natural log of other things, not just x. But in this case, it has to be just x. So derivative of the natural log is 1 over x. Derivative of the log of any other base, you do, it's kind of like e to the x and a to the x. You do 1 over x times 1 over the natural log of the base. In this case, if we had times, maybe don't write this in your notes, but if we had times 1 over the natural log of e, natural log of e is 1, so this is really just times 1. So you don't need it. If you wrote it, would it be wrong? No. All right, so you could remember the same formula for both of them if you want. So first one, derivative of y equals 5 natural log of x plus e to the x. Y prime, our 5 is going to stay there. Natural log derivative, that is 1 over x. Derivative of e to the x is e to the x. All right, I would recommend maybe rewriting that with the 5 in the numerator, and you could do that from the beginning if you wanted to. You don't have to take an extra step to do it. For this one, log base 5, derivative of that. So derivative of log base 5, you're going to do 1 over x times 1 over the natural log of 5. And then derivative of 2x is 2. And derivative of 7 is 0. You could leave it this way. You could combine it as a fraction. I don't really care on that. Usually if it's simple simplification, I go ahead and do it. If it's more complicated than that, I don't worry about it. All right, so here's one for you to try. And then this last example, I have the natural log, really there should be parentheses there, natural log of x squared. So I said if there's anything other than x right here, you can't take the derivative. But if we can rewrite it to make it just the natural log of x, then we can. And when you have a log, remember we have those properties of logs that if it's multiplication, you can change it to addition. If it's division, you can change it to subtraction. If there's a power up here, you can bring down the power. So that's what we're going to do. And then the derivative of that, we leave the 2, and we take it times the derivative of the natural log of x, which is 1 over x, or just 2 over x. So that's that.